Hello everyone, welcome to 526 Database Management. This is week 4. Last week, we learned how to run queries in MySQL Workbench. For this week, there's no PowerPoint, everything is hands-on. So I'm going to use MySQL Workbench's working environment as the teaching environment for the class. And this is the typical window you see when you open MySQL Workbench. And for better illustration, what I'm going to do is I'm going to hide the left and right column as well as the bottom column for a larger area for you to see. By click on the three icon on the top right window, you can actually hide some of them. So a quick recap of some general rules when we run SQL queries in MySQL Workbench. First, in SQL, to add comments, just like anything that you see in the gray, showing as gray text, those are comments. To add comments, just use two dash or two minus sign before any comment, which can start from the beginning of the line or from middle of the line. So those are the examples that comments actually start from the beginning of the line. So all those SQL is not going to write because those are comments. And also, please note, SQL is not case sensitive. So basically, select with a capital letter S, or select all capital letter, or select all lowercase, all mean the same thing for SQL. And sometimes we use capital letter or capital the first letter, etc., for kind of better illustration, and as well as for table names, column names. But again, table names and column names are not case sensitive either. So basically, you can use either whatever defined as the table name or column name in the database structure, or you can use all lowercase or all uppercase. But for clarity, for table names and column names, it is better for us to use what is ever defined for that table and for that column. For SQL keywords like select, we do have the freedom to choose whether we want to capitalize one letter or capitalize every letter. And also, I would like to emphasize again, in SQL, the semicolon determines the end of one SQL statement. Especially when you have multiple SQL statements, it is very important to put semicolon at the end of the statement. Do not put semicolon in the middle of your statement, otherwise you will experience errors. And always put the semicolon at the end of each statement for best practice. Those are some of those brief recap of some of the general rules when we write SQL scripts in MySQL Workbench. Okay, now let's focus on chapter 5 of the textbook, the data types. And actually, for SQL, we didn't mention in the first few weeks lectures, but we have some exposure of the data types. For example, characters, numerical values, or date and time values. To have us better prepared for the later sections, we're going to spend some time on those three different kind of major categories of data types in MySQL. The first step is let's focus on character constant. Constant in this particular one is something we're going to illustrate in this section, but in the future, we're going to have character variable for a particular column. But now let's focus on constant. For character constant, which is identified by any content that inside two single quotation mark. So for example, right here, we have the single quotation mark and single quotation mark, and everything in between is actually a character constant. To actually show what is a character constant, we can use select statement. So in MySQL, we can test constant or expressions we're going to discuss later with select statement, and we'll use it a lot for this week. Okay, now let's write. What will happen? We write, we highlight, we click the icon here. It shows this is a character type constant. Basically, this is whatever we put into the quotation mark, the single quotation mark. And you may wonder, how about I want a single quotation mark in my character constant? Then how can we do it? We can do it by using two consecutive single quotation mark within the two single quotation mark to represent a one single quotation mark. So let's do this. We write, we're going to see that it's customer's email address. So basically, two consecutive single quotation mark is a representation of a single quotation mark in the constant character constant. The main reason is because we already used the single quotation mark as the beginning and the end of definition. So this is basically how we can define the single a character constant. For characters, one common function is concatenation, which combines multiple character constants together. Please note in MySQL, the concat function is used for concatenation, which is different from what is illustrated in the textbook. In the textbook, it's used two vertical bars as concatenation. But for MySQL Workbench, these two vertical bar means different things, and the concat function is basically the same as what is illustrated in the textbook of two vertical bar. So whenever you see the two vertical bar in the textbook for the character constant or character columns, you have to replace the whole thing with concat function. The concat function is very easy to use. Let's see, for example, here I have four different character constant. The first one is my name is column. So this is the first character constant. The second character constant is space. The third one is Mike. The fourth one is a space. The fifth one is Lee and dot. So this is 5 different character constant. We can actually use concat function to combine all of them. And of course, each character constant is separated by a comma from all the others. Okay, let's see. Let's what's going to happen when we run this. Okay, it shows my name is Mike Lee. So basically, this is one constant, one character constant, and concat function is very convenient when you have different character constants and you want to combine them together. Character data type is very important in database, as many of the aspects of the data are presented by characters such as name, street address, product name, product description, etc. Correspondingly, column for this information will have character data type. In fact, there are many different character data types as listed in this web page for MySQL. And in this chapter, we actually only cover two different kind of types: the char type and the varchar type. Char type is basically, there's actually, when you define in your table, you have also a option. This option is a integer, can be between 0 and 265. Basically, there's a fixed length for the character. Another one is the variable character data type, where n is between 0 and 65536, and the variable, which basically it can contain variable that is up to that length, the maximum length, but it can store any variable, any information that are actually smaller than this length. And this character char variable or the column, it will actually have everything have the same length. If the information is less than, and in the database is going to add in space at the end of the character string. Let's look at some examples. Again, we're going to use the sales order example that you created last time, and we're going to show all the tables there. And actually, there are many tables in this database. Let's look at the customers database. The describe statement is actually can show us all the columns information. And here's the information. Okay, in the customers table, we have like customer first name, customer last name. They are varchar type, the data type, the variable character. Both of them have the maximum length of 25 characters. In customer street address is also a varchar type with 50 characters as the maximum length, etc., etc. And we do not have fixed characters in this particular table. Every character's type data are the varchar type with different maximum lengths actually. And okay, so that is a brief introduction of that's the brief introduction of the character data type. Now let's go to the next stage. The next stage is numerical constants or numerical data types. Numerical constants, which is defined by our typical numerical expressions such as 56, negative 9.6, or 2.5 e to the negative 3 power, 10 to the negative 3 power. So all those are numerical values. In SQL, we can actually look at it. What are those really mean? Like for example, this one, we again use the select statement. Actually, it's return 0.0025. That's 2.5, 10 to the next 3 power. And for numerical constants, we can apply the typical numerical operations such as plus, minus, multiply, and division. We also have the ABS function, SQRT function, exponential function, seeding, floor function, etc. Those are the typical operations that we can apply to numerical constant. A full list is at page 125 of the textbook. And as we learned in the past, when there are few operations that are involved, always use parentheses to make sure the order of the operation is what you want SQL to apply. So for example, this is very similar to a lot of the programming languages, how you write numerical expressions, and it's going to actually calculate everything and return the number. In this particular one, because we have 3.6 and square root of 21, so at the end of the day, the whole thing is converted into a double precision. We're going to mention that later. So we can also apply some functions, like the floor function is basically going to find the closest integer that is less than that exact number. So you can check all the different functions at page 125 for numerical constants. And similar to the character data type, for numerical values, there are many data types too. And there's a whole list right there for this link. And in today's lecture, we're going to cover a few. There's a small int, which is small integer. The signed range is between those. The signed range, which means it can represent both positive and negative numbers. And the int is a normal sized integer. The signed range is between those two numbers. The decimal, which has two options m and n, is a number with decimal point. M is the total digit, n is the decimal digits. Float is a small single precision floating point numbers, and the value is actually between those two numbers. And double is a normal size double precision floating point numbers, and it is between those two numbers. So it's a huge range for double precision, and for float it's a relatively smaller range, but it is typically good enough for us for a lot of the database usages. Now let's look at some examples, the data types. For example, let's look at the order detail table. We found out that in the order detail table there are 4 columns, and all 4 of them are actually a numerical data type. So the order number is an integer, and the product number is an integer as well. The quoted price is a decimal with 15 total digits and two decimal point digits, as well as the quantity ordered is a small integer. So those are all numerical values. Now let's cover the last major data type, which include date, time, and date time. So this type of data are used to identify year, month, day, hour, minutes, second, etc. Usually these information are first presented as characters, and then we can use the cast function to convert it into date, time, or data time. Once they're in the right data type, we can apply a list of date time operations as listed at page 740 of the textbook. The date time feature are very important, as we need to generate a report based on date and time, as well as select a subset of the specific date and time intervals. So let's first look at those date time and date time constants. As I mentioned earlier, usually anything between 2 quotation marks is a character. So 2016-01-28 is a character, but we can use the cast function, which convert one data type to another. Let's do this. We're going to convert that into date. Okay, now this is no longer a character, but a date, right? Which means year 2016, January 28th. And we can convert those into a time. So basically this become a time. Time is 24-hour format, And also we can convert date and time separated by space as a data time data type. Now it's become a data type. So there are many useful functions that can deal with date and time. We will when we call those functions, sometimes it will automatically convert characters and integers into corresponding date time type. And for example, the addDate function is basically going to convert a date object and add a number of dates to that object and then return the result. So for example, we have 2016 January 28th. At 5 days, it's going to automatically return 2016 February the 2nd. And this is date time format. We add a 3 hours to that time. So it then is become from hour 17 to hour 20 of the day. So here there's another keyword called interval. The interval basically is going to tell the program that anything that after the interval is going to be a specific time amount in a particular unit. So it can be 3 hour or 3 day or 3 minutes or 3 second or even 3 year, 3 months or 3 quarter. So the interval is going to tell the SQL that anything that I mentioned later will become a specific data types or time types. So interval 3 hours is going to add 3 hours to the previous date and time. And let's see another one. That is, I'm very specifically convert this one as a date and then plus when you have the data type, the plus sign actually means you're going to add some of those time quantities to your variable or constant. Let's see what's going to happen here. Okay, so this is 2016 January 28th, and we add 1 quarter to that. Is actually going to return 2016 April 28th. So we can use the minus sign as well. The minus is actually going back in time. So we have 2016 January 28th. 17 is the hour, 34 is the minutes, 58 is seconds. We have the interval 30 minutes, which means we define the 30 minutes is a particular time interval, and then it's become 17 is hour, 04 is minutes, which is 30 minutes earlier than this particular date time. So data time is very useful, and this is actually we showed how we're going to use it. We can look at the order database and to see are there any columns is actually using date and time in that particular one. Actually, we do see the order date and shape date have the type date. So anything from that 2 columns can be any of the date related functions can be applied to those 2 columns. And we just mentioned expression, but what is expression? Expression is some form of operation involve numbers, character strings, or dates and time. We have already seen some examples above. Like for example, we have already seen some of the expression above, and here we include more examples with multiple data types. To make sure constants with different data types can be used correctly in expressions, we need to convert all constants in an expression to the same data type using the cast function, similar to the above example in date and time section. The cast function convert a value of any type into a value that has a specific type. The target type can be any one of those following types. We have the char, we have date, we have time, we have decimal, signed, unsigned. Those are integers. So let's for example, we can convert a character into an integer, and then after that we can do the operation plus another integer. And as you can see, the final result is an integer, which means when we convert a character into a signed integer, it's going to truncate the decimal point out of that, become 223 and plus 64, 67. And sometimes you can actually add those two things together because in the MySQL software is actually automatically do this conversion for you. In this particular one, it's actually use that as the exact number and plus another exact number here. We can also this is also kind of like automatic conversion because concat function only apply to strings or characters. In this particular one, we have numerical values, but once we run that, the concat function actually convert everything into character, and then the concatenation to combine them together. So those are some of those functions, like cast function to convert one data type to another. Now what we learned above is basically the character, numeric, or date constant. Anything we learn for those constant can be applied to columns in a table as well. And the expressions and the functions will apply exactly as the same way to the column names. The only difference is that instead of using constant, we will use column names. In the following example, we're going to show you some of the detail. Let's look at the customer table again. Okay, in the customer table, we have customer first name, last name, etc., and area code and phone number, etc. How about if somebody's asked us, can you give me a list of customers' first name, customers' last name, and their number in a particular order and in a particular way, like the phone number, the area code is within parentheses and a dash between the phone number, the area code and the phone numbers. So in this particular one, we can do that by using the customer table. Basically, first let's create a customer name. The customer underscore name basically contain the first name and space and the last name. We can use concat function to combine the customer first name column and customer last name column together with a space in between. And we can rename whatever we have created as a customer underscore name. So as is another keyword. It's basically we can give a name for a specific expression, and then the comma here indicates the first operation is done. The second operation is also a concat function, which add in the parentheses, which also convert the customer area code, which is a small integer. We convert that into a character and then combine the whole thing with customer phone number with a character as well and separated by a dash. And then we name everything in this operation expression as the phone underscore number. We use the as keywords again. And we select everything from the customer table. Let's see what will be the result. When you write, you see there are two columns. The first one is customer underscore name as we created right here. And the second column is the phone number as we created here. So now you have two columns and they have all the information you need for the question that you are asked to solve. So this is a simple example how we can use functions to a column names to create new information. In this particular case, this is a character data type, and it is the column name, and we do not put this a single quotation mark around column names, and we use column name as it is to reference the column names we want to combine together. So let's briefly summarize. In this above query, we basically we can actually break lines as needed for easy reading. We are actually creating two new columns in the select statement, and we can put everything in one line, but for easy reading we separate those in two lines. And we also used concat function and cast function in the expression, and we select in the select statement we can use the as keywords to give a column name for the result of a specific operation or expression. And also please remember the proper use of comma and semicolon. For comma we used here, so basically within the concat function, any different segment we need to use comma to separate, and the same thing here. And also we need to use comma to separate two different kind of expressions. And also it is always best practice to use semicolon at the end of the query to indicate a clear end. So let's see another example. That's basically we can apply operations into different columns. Let's look at the order table again. In the order table, we have the order date and ship date. And how about if somebody is asking you for all the orders, how many days actually is between the order date and ship date? And we can do that by using this query. We can select ship date minus order date as shipping days from orders. In this particular example, we create a shipping days column which contains the number of days between the order date and ship date. So that's basically a particular query we can create. I can also introduce two more functions. Actually, you can use a max and the minimum function, which is going to return the maximum shipping days and the minimum shipping days from the query. And let's write. Okay, we found out the maximum shipping days is actually 8,000, more than 8,000 days. The minimum shipping days is 0. In that particular example, very likely there's probably some default number in the shipping dates or the order dates. It actually shouldn't be taking that long. That's actually a good way to identify in your table are there any kind of like wrong data. We can also, some people may ask, can you give me the, as the previous query, there are different kind of shipping days. There are shipping days, and we want to know how many distinct shipping days, how many unique shipping days among all different orders. And we also want to order this in a ascending order. So let's see what will happen. When we run this, the unique shipping days, this is basically the difference between the order date and ship date, is 0 days, 1, 2, 3, 4, 70, 71, etc. to 8,870, etc. Those are all the unique shipping days that we created. So that's another example of using uh, um, different operations, expressions, as well as using the as keyword to name a particular new column. So those are some examples we see from different data types. And now let's consider a specific data type. For any of those data type, you actually can have null values. In SQL, null represents a missing or an unknown value. It is not 0 from numerical data type. It is not one blank space or zero length string for character data type. It is really about missing or unknown. So any operation with null will return null, which is equivalent to say when unknown are involved, the result will be unknown as well. So let's see what will happen. Like for example, we are adding null with 23, and let's see what will happen. It's going to return null, which means anything that add null is become a unknown. And that's for numerical value, and we can also apply for a character string value as well. In this particular one, we are concatenation for a string with null, but the return is null as well. So whenever the unknown is involved in the operation, the result become a unknown, become a null. So that is something we need to keep in mind. Okay, that is basically what we covered for chapter 5, and let's end the video now, and I'm going to actually start chapter 6 as a new video.